Welcome back to Beginner's Guide to Understanding Chemistry. We are on Lecture 7, Molecular and Ionic Compounds. Ionic versus molecular compounds. In the last lecture, we distinguished ionic and covalent bonds. When a metal bonds with a nonmetal, the metal donates its valence electron or electrons to the nonmetal. This arises when the difference in electronegativity between the two atoms is greater than 2.0. This process forms two ions or charged atoms. The metal becomes a cation, a positively charged ion, and the nonmetal becomes an anion, a negatively charged ion. This type of bond is called an ionic bond. We have the periodic table with all of the electronegativity values listed below. For example, when lithium bonds with fluorine, lithium has an electronegativity value of 1.0, while fluorine's is 4.0. 4.0 minus 1.0 is 3.0, and this can be thought of as an ionic bond because the difference in electronegativity is greater than 2.0. On the other hand, when two nonmetals bond, they do not transfer electrons, but share them instead. This sharing is even if the two atoms have similar electronegativity values. The difference in electronegativity is less than 0.5, and we call this a non-polar covalent bond. For example, if I have hydrogen bound to carbon, hydrogen's electronegativity value is 2.1, whereas carbon's is 2.5. The difference between these two values is 0.4. Thus, this is considered a non-polar covalent bond. On the other hand, if the sharing between electrons is not even because one atom has a much greater electronegativity value, i.e. the difference in electronegativity is 0.5 to 1.6, this type of bond is called a polar covalent bond. For example, if I have the atom hydrogen bound to the atom chlorine for hydrochloric acid, hydrogen's electronegativity value is 2.1, chlorine's is 3.0. The difference between these two values is 0.9. Thus, this is called a polar covalent bond. But to make it easy, in reality, an ionic bond is between a metal and nonmetal, and a covalent bond is between two nonmetals. Those electronegativity values are really just used to differentiate a polar covalent bond from a non-polar covalent bond. And now let's look at generating ionic formulas. When a metal and a nonmetal form an ionic compound, they do so in such a way that they balance out each other's charges. Let's take the following general statement, where A in this statement is the metal and plus X represents the charge of that metal. Because group 1A and 2A elements tend to be metals that are positively charged, that's why we have a positive X here, where B is a nonmetal and negative Y represents the negative charge that nonmetals typically take on, such as halogens. The way to get an ionic formula from this is to take the superscript plus X, put it as a subscript in front of B, and take the superscript negative Y and put it in front of A. As we'll see, because positive X and negative Y cancel each other out, when we write this, we'll write this as a subscripts with no charges because they've canceled each other out. To solidify this, let's look at an example. Let's run through an example problem together. Predict the formula of the compound formed when Na sodium bonds with F fluorine. Sodium has a positive 1 charge. Fluorine has a negative 1 charge. We're going to take each superscript and kind of crisscross it, putting it in front of the opposite letter, and we'll get the following formula: Na1F1. A lot of the times, actually every time in chemistry, although it is correct to write it this way, because ones are implied in usually mathematics and chemistry, we can just write NaF. Let's run through one more example problem together that's a little bit more challenging. Predict the formula of the compound formed when Mg magnesium bonds with N nitrogen. Try this on your own before I walk you through the answer. Pause the video. Okay, now that you've hopefully paused the video, the charge of magnesium is what? It's positive 2. The charge for nitrogen is what? It is -3. We'll do that cool crisscross method. We'll take the positive 2, put it in front of the nitrogen, the -3, put it in front of the magnesium, and what we'll end up with is Mg3N2. And this sort of makes sense. Let's talk about why. Charges. Magnesium equals, the charge of magnesium is positive 2, and we have 3 of them. So positive 2 times 3 gives us a total charge from the magnesium of positive 6. Nitrogen, on the other hand, has a charge of -3, but there are 2 of them. -3 times 2 equals -6. They both cancel each other out. This is a great way to check your work, and I highly encourage that you guys do it. And to solidify the knowledge that we've learned, you guys should work through these example problems. Predict the formula of the compound formed when magnesium bonds with fluorine. Predict the formula of the compound formed when calcium bonds with oxygen. And predict the formula of the compound formed when sodium bonds with oxygen.